Hi everyone, Kent Larson here from Smart House Electric. I'm going to give you a 101 here on Ohm's law and how to use that for troubleshooting. So you got three components in electricity that you adhere to. And the first one, voltage, measured in volts, and using the letter U when we calculate it mathematically. And how we relate to this to volts is, if we want to explain it with water, is that this is basically pressure. So that's our analogy for volts. Resistance, that is measured in ohms. We use a symbol for this looking like this. It is called omega. The letter that we use mathematically when we calculate this is R. And for the water analogy again, to explain what this actually is, will be the size of the hose or how much you squeeze the hose. So the passage of the water. So we're going to write hose here. Hose size. All right. So these two elements here is going to determine how much current we have running. The current is measured in amperes. Most people just call that amps. It's just short. The letter that we use for our calculations are I. And this, to our water analogy, will be flow. So we got pressure on a certain size hose. We're going to have how much electrons are going to flow through there. So if you increased your pressure on a certain size hose, you will also increase your flow. Let's look at how that mathematically looks like. And there's a formula to explain this, and that's Ohm's law. So you got U equals I multiplied by R, which is the same as, if we move the formula around, we want to find I, it will be U divided by R. So as you can see how this affects each other is that if your resistance goes up on a given current, you will have more voltage. If your voltage is of a certain size and your resistance goes lower, you're gonna have a higher amperage. So let's calculate a couple of examples here. So let's take this guy here. This is what most of the time that you're going to be having. You're going to know your voltage and you're going to know your resistance, and you're going to find out how much is this going to be pulling. This is if you make some kind of a change to a circuit, or you're trying to figure out how is this going to affect the circuit, what I'm about to do? And so let's see here. Let's say that we have 10 volts. And we have, let's do that, and 10 ohms. That up in one another is going to give 1. So we're going to have 1 amp on this circuit. So what happens if we change some of this? Let's say if we change the voltage down to 5 volts. Still 10 ohms. Well, now all of a sudden, we got 0.5 amp, half an amp, by lowering the voltage. Let's make another change, another example here. Let's change to another color to keep it a little bit more separated here. So let's change this, go back up to a 10 volts here. And let's do 5 ohms. And we now have 2 amps. And that's Ohm's law. All right, so let's put this to practice. So let's first just quickly write our formulas down. So the fundamental Ohm's law, U equals I multiplied by R. And that was also, just to recap that, of course, U was volts and I amperage and R resistance. Okay. Yep. And so the elaboration of this, if we want to single one of the other components on the other side, our amperage, to get that, we'll need U divided by R. So our voltage divided by resistance will give our amperage. And lastly, resistance, that will be our voltage divided by our amperage. So these are our formulas to find the unknown that we like to find. I got a little resistor here for our, I know that's very small, but let's put some power on it. And this little guy here is a 1.5 kilo ohm resistor. And we're using these expressions, kilo, milli, and what they mean is that in this case here, kilo means 1,000. So 1.5 kilo ohm is the same as 1,500 ohms. Our circuit over here, we're going to be using, we're going to give out 10 volts. The power supply I'm going to be using is going to give out DC. That's a whole another thing. We're going to get into that in another video about the different kinds of power. But for now, this Ohm's law is always going to stand by. It doesn't matter if it's AC or DC. This is the fundamental calculation method to figure out how much you have of each. So we got 1,500, we got 10 volts. Now we can calculate how much current are we going to be having. And so let's put that to a test. So which formula are we going to be using here? We got 1500 ohms, we got 10 volts. We're going to find the current. So we got this guy up here. This is the formula that we're going to be using. And so I equals U divided by R. And so what that will translate to is that we have 10 volts and 1500 ohms. And that's going to give us a really small number. Something like that. I can't really look at that. That's really tiny. So again, like we used with the resistor up here, we gave it a prefix so that it's a little bit more readable. And in this case here, we're looking for a 1000 part that will make it easier to look at. So in the end, 1000 parts, we got the hundreds, we got the tens, and we got the ones. So we add at 6.67, and 1000 parts is milli. So we're down in 6.67 milliamps. So let's see if our numbers here are matching reality. So let's bring in our multimeter here. We got it set for what we expect to find, something in milliamps. Let's move this guy over here. So we always have one lead in common. And then this one here says milliamps, and this one over here says 20 amps. So we expect to find a small size, so we're in milliamps, and it says here milliamps. This symbol down here, the section that we're putting it in, is showing these dashes here, and that means that it's DC. So we are going to need that piece of information for this measurement. AC is this sinus curve here. So, all right, let's hook it up. And so, and we're putting it in series with our load, our little resistor, in order to measure the current. Let's put some power on. And how about that? We have it in milliamps, and we're showing 6.6. 6. And then you start flipping there, which is 6, 7. So that's pretty accurate. That's pretty accurate. Now, what if our voltage went up? So let's bring in a voltmeter here so we can follow that. Size. And as I mentioned, I don't know actually if I mentioned that, but so current is measured in series. Like you just saw, we have the power going in on one side and then coming out on the other side, and it goes into the our amp meter and then back. And so to measure voltage in this case, let's make sure that we are in voltage mode and for DC. And now we're going to measure that right across here. And as you can see, we're not exactly on the 10 volts according to this voltmeter. However, it could be that it is just a tiny bit off, but let's just kick up a notch here on our power supply. That went up a little higher. So you see, it's pretty accurate. It's very, very accurate, actually. So let's say that if we went up in voltage, let's say we go up to 15 volts. Let's go up to 15. And look at the amperage. Oh, I went a little high there. There we go. So 10 milliamps are we up to now. So on a given resistor, if you raise your voltage, you're going to raise your current. So now let's change our resistor. So we're still going to have the power coming in here. Our lead going to our amp meter. This is a 3.3 kilo ohm resistor. And we're still going to measure some voltage across here. So we're going to maintain the same voltage. Well, where we left off, we have raised our voltage to 15. So let's see what happens with that. So we're looking for I. We raised our voltage to 15. And now we have a resistance of 3.3 kilo ohms, which is the same as 3,300 ohms. And let's see what that comes out with. I'm going to dial it in on my calculator here. Little obscure number here again that we're going to have to change into something more presentable. 4.5, which would be the same as 4.5 milliamps. Let's see if that holds true. So let's put some power on here. How about that? So we're about that 15 volts on our voltmeter from our supply. And not too far off. So this is Ohm's law and how these different elements affect each other. Resistance together with volts is what dictates the amount, the flow of the electrons, which is your amperage. So your amperage, when you look at your circuit, you're not really looking at how much the circuit is giving. It's just the capacity of that circuit. So if you have a 80 amp circuit for your tanning bed, then it's the capacity to give 80 amps. But really, it's a play between your voltage and how much resistance on that voltage there is on the machine that dictates how much amperage is going to be pulling from you. So the next video I'm going to be showing you is how parallel and serial is affecting when we connect different electrical components together, and that is what the famous Kirchhoff's law is coming into place, and it's not that bad. So please stay tuned and watch the next video. Thank you for watching.